Hi guys, welcome to your Chapter 5 Lesson 3 notes on slope-intercept form. By the end of the day, you'll be able to write and graph linear equations in slope-intercept form. Let's establish some definitions. I want to tell you what the linear parent function is, but before I can, a parent function is just the mother of all functions. I'm just kidding. It's the simplest, it's the most basic function of a family. So when we talked about linear functions, remember linear just means it's in the shape of a line. So the very most basic line you can have is y equals x. That's it. It's super basic. In fact, that graph is right here. It's this guy right there. So the most basic line graph is y equals x. And anything we do to that is just going to change that graph a little bit. So a linear equation is an equation that, of course, you remember, models a line. I'm just going to, a line. Okay. So if I take this and, I change the slope, I want to make it twice as high, and I put a little 2x in, and then it gets super steep. Or I could, add a plus 1 right there, and that moves it up 1. That's so fun. If I make this slope negative, then it goes down like that. Okay, so we're just messing with the function, but you'll see each of them has a y equals x inside. Y equals x, y equals x. That's how you know it's a line. Okay. So examples of linear functions are anything that has y equals x. You can have y equals a half of an x, y equals negative half of an x. So you can add 1, and that's great. What you cannot do is you cannot put any exponents on there. That's not okay. You can't have y squared equals x, which is also known as y equals the square root of x, like that. Okay. You can't have y equals 1 over x. Those fractions aren't fun. But you can have something times x. You can have something plus. You can have x plus something. That's fine. So you can have things like y equals 2 times x. You can have y equals x minus 3. That's great. You can add and subtract, but don't go any more than that. Okay. Another special term that we have, we already talked about slope a little bit, right? We talked about rise over run when we were looking at direct variation. Sorry, your direct variation was your k right here. It tells you how high up you can go. But we didn't talk about a y-intercept yet. Just like in football, when you intercept a catch, you run into something, or if you intercept a transmission, the enemy transmission, you catch it. Okay, right? The y-intercept is where the line runs into the y-axis, is where the y-axis catches the graph, in essence. So that's exciting. You'll notice that the y-intercept is right on the y-axis right here. That means your x doesn't go anywhere. You don't go over to the right anywhere. You don't go over to the left anywhere. Your x is 0. So on your what's it called? On your y-intercept, your x is always going to be at the point 0 something. It's going to some number b, whatever that is. The y value is going to go up and down something, some number. We're just going to call it b. Okay, so your y-intercept is where your graph crosses the y-axis. So this graph has one here, this graph has one here, this graph has one right there. Okay. Now, we can define a line using the intercept. We need 2 things to define our line. We need the y-intercept, and we need the slope. And that gives us a special form of a line called the, wait for it, slope-intercept form. So here's our key idea of the day. As long as you know the slope and you know the y-intercept, you can write it. You can write the equation of the line, and it will always be in this form. You'll say y equals whatever your slope is times x plus whatever your y-intercept is. Okay, so as long as you know your slope put it right there. And as long as you know your intercept, put it right there. Now for slope, we always use this letter M for slope. Shows how the graph moves. And we know what our intercept is. Our y-intercept is B. So it's going to be up B, this distance B. So just B. And there it is. Y equals mx plus b. Know it, love it, memorize it, commit it to your heart and brain. We're going to use this so much today. Slope-intercept form, y equals mx plus b. Okay, so let's use that pattern right now. Here we have that same pattern. Y equals mx plus, I'm gonna copy it because I want my colors. Y equals mx plus b. Oh, hey, look, that's in that same pattern. How convenient is that? We've got y equals, our m is -5. Our b is 7. Super duper. So what is our slope? Our slope is -5. And what is our y-intercept? Our y-intercept is 7. That's it. End of problem. Those go fast. I like them. Now we can do that, but backwards. Let's try again. Okay. Write the equation of the line with its following slope and intercept. Okay. So our slope is 13/2. Our y-intercept is 9. I should have highlighted this whole thing. Start over. And it's as simple as plugging in these values. Okay, our slope is 13/2. Our intercept is 9. Done, we are done. Y equals 13/2 x plus 9. Yay! If you prefer and you want to write it this way, you want to say y equals 13 times x all over 2. That's also great. That's fine. Let's do another one. We're going to insert our slope-intercept form. And this time they tricked us. They put the intercept first and then they put the slope. But we can read, so we're not gonna get tripped up by that. No, sir. Here we go. Okay, our slope is 3. Ta-da! And our y-intercept is a -45. Check that -45. This is fine as long as you put like your -45 in parentheses. That's okay. If you want to save yourself some time, you can just do -45, and that's great as well. Hey, guys, if you got that, you basically got the lesson. But now let's use pictures. Look at this graph. Well, what do we need to find out? We need to find out what is our m and our b. Well, I don't see any m's on here. So I'm going to quick remind myself, hey, m means slope. Okay. And b means y-intercept. I'm going to abbreviate because of time. Sweet. Now let's figure out the slope. We can totally use our slope formula if we want to. If you really want to, you can take, I remember that slope equals y2 minus y1 all over x2 minus x1. And I'm going to plug in my y values from my 2 different points and my x values from my 2 different points and whatever that comes out to be. Or you can remember, you know what? Slope is rise over run. And I remember that rise is the difference in the y's and the run is the difference in the x's. And I'm going to use that shortcut. So let's look at our graph. Okay, what do we know? Well, we see that it goes through this point right here, which is over 0, up -2, or rather down 2. Where's another clear point? Here's a clear point. This is over 1, up 0. That's going to be super convenient. Where's another clear point? Oh, here's 2, 2. So if you're a ballerina, you can use that one. That was a joke. Okay, anyway. Or if you just want to make your whole life difficult, you're going to say, I'm going to use over 1/2. Down, -1. So pick any of those 2 points and figure out what is your rise over run. I'm going to use the 2 easiest ones, which are these 2 guys right here. Okay, so my rise is how far up do I go? I go from -2 up to 0, which is 2. Yay, because the difference between -2 and 0 is in fact 2. And now I need to figure out my run. going to go for a run from 0 to 1. And I found that my run is 1. Sounds like a Dr. Seuss book, but it's not. Okay, so our rise over run is in fact 2 over 1, which is just 2. Yay, we found our slope. Okay, that was fun. Now what's our y-intercept? Oh, I didn't highlight the slope. Slope. Y-intercept. Well, y-intercepts are my favorite, you guys, because do you know how to find a y-intercept? You look. Oh, look. The y-intercept, remember, is where it crosses the y-axis. And where does our graph cross the y-axis? Right here. Right there. Where is that? That's -2. Our y-intercept is -2. Hey! We've got our slope. We've got our intercept. Put it in slope-intercept form, shall we? Remember, our slope is 2. Our y-intercept is -2. So we've got y equals 2x minus 2. Done. Check that off the list. Okay, cool. But what if we don't have a picture at all? What if they don't even give us the slope and we have to work for it? But that's okay. We can work for it. We know how to do this. We remember that slope is the difference between the y's. So we look at our 2 points. We've got our first point and we've got our second point. Okay, now let's take the difference between our y's. So we'll do -8 minus 1. -8 and 1. I forgot this is equals. Okay, -8 minus 1. And the difference between our x's. We've got 5 and 2. So 5 minus 2. Now let's figure out what is that. How far up did we go and how long of an x did it take us to get there? -8 minus 1 is -9. 5 minus 2 is 3. That reduces to -3. -3 over 1 if you prefer, which is -3. So our slope is -3. And guys, it won't always work out to be a integer like this. You might have fractions sometimes, and that's okay. We love fractions. So we have our slope. Yes. Now we need to figure out what is the y-intercept. Well, I don't know. They didn't tell us. We have to find it. Let's put all of the information we know together. Well, we know we want it to look like this. And we know it, okay, we want it to be y equals mx plus b. And we know our slope is right here. I accidentally erased it, sorry. Our slope is -3, so we're just gonna boop, boop. Actually, so you can track my work, I'll leave that there. Hee. And then we'll boop, boop, get rid of this guy and plug in a -3. Okay, super duper. But we have too many variables. We have too many unknowns. But guys, we actually do know something. You see this x right here? And you see this y? What this equation really represents, what the equation of a line really represents is, hey, this is the set of all x's and all y's that will make this equation true. So if you plug this point in, for example, if you have x equals 0 and y equals -2, is it true that -2 equals 2 times 0 minus 2? Because all we did was plug in here. You're trying to tell me that -2 equals 0 minus 2? Yeah, that's what a line is. A line is just a set of all points that makes this equation true. So, because we know that, we can actually plug in x, y points to find our y-intercept. I like this one because it's really simple. So here we know x is 2 and y is 1. So we're going to take this point and plug it into our equation. Wee. Oh, come on. Wee. Okay. So y is 1, x is 2. Everything else is the same. Equals -3 times 2 plus b. Okay, well, negative 3 times 2 is negative 6. 1 equals negative 6 plus b. I ran out of room. In order to get this b all by himself, we just need to add 6 to both sides. So 7 is our b. Our y-intercept then is 7. Hey, now we have all the information we need. For slope-intercept form, we have y equals our slope, which is negative 3, times x, plus our y-intercept, which is 7. And that's it. That's how to find the equation of a line. So sometimes you might feel overwhelmed and you're like, oof, I don't know where to go. But that's okay. Just take what you do know and see where you can go from there. That's your life lesson of the day. Okay. Hey, we've got 2 more. Thanks for sticking with me. I'm gonna teach you the shortcut first. So when you have y equals mx plus b, my hint for you is that m, which you know is the slope, shows you how the graph moves. It gives you your rise over your run, right? That's what slope is. M for moves shows you how far up do you go and how far over do you go. Rise over run. Okay. And b shows you where your graph, yeah, it's the y-intercept. That's cool and technical and stuff, but that shows you where your graph begins. B for begin, like start, right? Like a starter thing. So this is another key idea. This will help you remember how to graph. So I'm going to show you this and show you how it's really just this. So we're going to begin at our y-intercept. Our y-intercept is 1. So go over 0, up 1. There it is. I even covered up the 1. But that's our y-intercept. Over nothing, up 1. In fact, I'll make it a little smaller so our graph can be all precise. Boop. And then I'll do like this so you can see it. Ta-da! Okay, cool. And now we need to follow the slope. Well, what is our slope? We know our slope is 2. Great. But remember, slope equals rise over run. Equals rise over run. So you can also say that that's the same thing as 2 over 1. So you go up 2 over 1. And that's exactly what we're going to do. We're going to go up 2, so from 1 up to 3. So up 2, actually, like this. Up 2, that's just a starting. Up 2 over 1. Now you notice that that distance 2 lined up with the numbers on the graph. If I even went on a smaller scale, if I went up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Oh, hey, I still get to the same point. That's because lines have the same slope across the whole graph. And now that we have, I never actually labeled that point. Here, we've got our second point. Actually, we've got several, technically. That's okay. Actually, I want to go this way. We connect them this way. Even if I zoom out, because I'm working notability, I can connect them this way and then just, I got a nice line that goes through all of the points. Ta-da, what a beautiful line we have. It's amazing. It's the best line I've drawn in the past, 20 minutes. Done. That's how you graph. Begin at the y-intercept, move with your slope. Okay, that's fantastic, but when are we going to use this in real life? Well, let's say you're just going to take a dive. Let's dive right in. Okay. So you have water pressure measured in atmospheres. At 0 meters, the pressure is 1 atmosphere. This tells you that... Oh, does it say? Yep, it does. Okay, I'll keep reading. The pressure increases by 0.1 atmospheres per meter. Write an equation in y-intercept form. Oh, y-intercept form. Whoop. that models the pressure, which is y, at a depth of x meters. So we're going to label our graph right away, now that we know what we're dealing with. X is depth in meters, and y is pressure in atmospheres. Here's my fun trick. Find a straight line for your label, so it's all flat and nice and neat, and then you just twist it. Weep. Okay, cool. Write an equation and then graph your equation. Okay. Well, what do we know? We need to figure out what is our slope and what is our y-intercept. Well, slope is how much it changes. They told us that right here. Atmospheres per meter. And check it out. We've got our units up here too. Remember, our y units is atmospheres. And our x unit is meters. So that shows us already, hey, look, we have a rise over run. Super duper. So that's going to be our slope. So I'm just going to take our slope and replace it. Haha. Okay. But what's our y-intercept? Well, remember, our y-intercept is whenever x equals 0. That's what our y-intercept is. In fact, I'll just put it right here. Okay. So we want to figure out what happens when you have 0 meters. Oh, hey, at 0 meters, guess what? The pressure is 1 atmosphere. Check that out. So we know that it's 1. Isn't that so cool? So cool. Math is so fun. Okay, so at 0, when x is 0, y is 1, which tells us that our y-intercept is in fact 1. Nailed it. Okay, hey look, we've got a graph. Okay, we've got substitute and slope. Oh, hey, I did that already. Yes, see above. We did that up there. Cool. Now let's plot the y-intercept. Okay, y-intercept is 1. Hey, I found 1. It's right there. Nailed it. Cool. Done. Now we need to follow the slope. Guys, our slope is 1/10. How do you go like up a tenth and then over 1? Well, I'm gonna show you a cheat sheet. Guys, here's a fact that's gonna blow your mind. 1/10 is equal to 1/10. Crazy, right? Yeah, but why is that helpful? Well, remember what slope is. Slope is just rise over run. And now that we wrote it as that's going to get gross. Now that we wrote it as a fraction, we can easily see, oh, hey, look at all my stuff. Oh, hey, we have a rise of 1. We have a run of 10. Whoa! So let's do that. Let's start at 1. Let's rise up 1. I'm sure that's a song or something, rise up. And then go over 10. Look, there's our 10 right there. Okay. Hey, check it out. Let's do it again. Just for funsies. Let's go up 1. I should go up 1 like that much. Over 10. Let's do one more time, just for kicks and giggles. Up 1 over 10. Okay, so we've got a point here. We've got a point here. We've got a point there. Now we can connect them all. Nailed it. Pressure. I mean, no pressure, guys, but this is your diving pressure. So if you dive down 30 meters, you're at 4 atmospheres. That's like 4 times the normal pressure of life. Ooh. So anyway, I hope you don't feel too pressured by this lesson. Key idea has been throughout here. Y equals mx plus b. It shows us how the graph moves and where it begins, and that's really all you need. And I hope you have a fantastic time on your homework.